discuss the numericals based on law of parallelogram of forces. In today's lecture, we will discuss some important numericals which can be asked in GTU exams. These numericals are taken from Atul publication, Mechanics of Solids by R.P. Rathelia, Atul publication. So you can see that if I am taking example number 1, then after this example, maybe it will be example number 2, it will be directly example number 5, or it will be example number 10 also. So just don't follow the number of the example. I have taken all important varieties in these numericals from the Atul publication book. You can refer that book also, and by studying my video and by studying from that book, you can easily understand these numericals. So let us start today's lecture in which we will discuss some numericals. Let us see example number 1. What is given in the data? There are two tensile forces, 50 kN and 40 kN, acting at a point with angle 60 degree between them. So you can see in the figure that there are two tensile forces applied at point O. First one is P, which is 50 kN horizontal, and second one is Q, which is inclined 40 kN. Angle between these two forces is 60 degree as shown in figure. Find magnitude and direction of the resultant. What we have to find? Magnitude means R and direction means alpha of the resultant. So we have to find R and alpha of the resultant force. So now P is equal to 50 kN, Q is equal to 40 kN, and theta equal to 60 degree. Now as you can see, our formulas are very clear. There are two formulas. First one is R is equal to P square plus Q square plus 2PQ cos theta. So by taking under root, R equal to under root of P square plus Q square plus 2PQ cos theta. And the second formula is tan alpha is equal to Q sin theta upon P plus Q cos theta. So you just replace the value and do the simplification in your scientific calci. You will get the answer. You can see here it is P equal to 50, Q equal to 40, again P equal to 50, Q equal to 40, and theta equal to 60 degree, the angle between two given forces. So by solving, you will get R equal to 78.1, unit will be kilonewton, as P and Q are given in kilonewton itself. Now, in the second formula, tan alpha equal to Q sin theta upon P plus Q cos theta. All the values are available. Q equal to 40, theta equal to 60, P equal to again 50, Q 40, and theta is 60. So now final answer will be alpha is equal to 26.33 degree. So this is the alpha, which is the angle of R with P, which can be defined as direction of the resultant also. So this is very basic numerical in which by replacing the given values in the given formulas, you will get the required answer. So this is just for the warm up. This is just for your practice. Let us see the tough numericals ahead. Example number next, which is example number 4 as per the Atul publication book. Remember this thing. So now let us see example number 4. Two tensile forces acting at an angle of 120 degree. Acting at an angle of 120 degree. So from the figure you can clear that there are two tensile forces. First one is P, which is 40 kilonewton, given over here, bigger force. The resultant is perpendicular to smaller force. So smaller force is defined like Q on the inclined side, and the resultant will be on the diagonal of the parallelogram. And it is given that the resultant is perpendicular to smaller force. So this resultant is at 90 degree with the smaller force. So this angle will be 90 degree. And the smaller force and find the smaller force and the resultant force. What we have to find? We have to find smaller force means Q, and also we have to find resultant means alpha. Alpha and R both means magnitude and direction of the resultant. So let us start with the data. What is given in the data? P equal to 40 kilonewton means bigger force, which is horizontal in the figure. Q equal to smaller force, we have to find. Theta equal to 120 degree. So from this figure, it is 90 and this is 120. So 120 minus 90, alpha will be 30. So alpha, we don't have to calculate. It's directly available from the figure, which is 30 degree. Now, applying whenever, just remember one thing, whenever alpha is available to you, then first apply the formula of tan alpha. So what is tan alpha? It is equal to Q sin theta upon P plus Q cos theta. What values are available to you? Tan alpha means 30 degree. Q is unknown, we have to find. Theta is equal to 120 degree. From the figure you can see over here, theta is equal to 120 degree. P is given in the figure 40 and again theta will be 120. So in this formula, the Q, force Q is only the missing value. So by simplification, in the scientific calci, cross multiplication, simplification like this. So by doing number of steps like this, like this, like this, you will finally get Q equal to 20 kilonewton. Remember this, after the decimal, you have to take 3 to 4 digits in your calculator. Again repeating, after the decimal point, you must have to take 3 to 4 digits so that you can get the perfect answer like Q equal to 20 kilonewton. Otherwise, the answer will be vary from my answer. Now, we have to find resultant magnitude, which is equal to under root of P square plus Q square plus 2PQ cos theta. So P equal to 40, Q equal to 20. Again P equal to 40, Q equal to 20 and theta will be 120. So answer will be under root of 500, which is 34.64 kilonewton. So here resultant will be 34.64 kilonewton. So this is the other type of example. In the first example, all the data are available to you. You just have to replace the values in the formula and you will getting the answer. But in this example, resultant is not given to you. One force is also not given to you. But the direction of the resultant means alpha is already available to you. So with the help of this, we have calculated Q and R. Let us see the next example. Example number 5. Now figure is not required, just formula is required in this data. What we have to find? The magnitude of two forces. Means we have to find two forces P and Q. Both are unknown. Such that if they act at right angles, if they act means case number 1. So here it is case number 1. If they are acting at 90 degree, right angle means 90 degree. Then the resultant is root 40 kilonewton means R equal to root 40. So you can take R square equal to 40. So this is the case number 1. But means case number 2. If they are acting at 60 degree, so in case 2, theta equal to 60 degree. Then the resultant is root 52 kilonewton. So R equal to root 52. You can consider R square equal to 52. So in the first case, R square equal to 40. In the second case, R square equal to 52. From both the cases, we have to find P and Q. So do something like that. Mathematically, you will find P and Q. Let us see. For the case number 1, we have only one formula. R square equal to P square plus Q square plus 2PQ cos theta. In the case number 1, when theta equal to 90, just replace all the values. R square equal to 40, P square Q square unknown, again PQ unknown and theta will be 90 degree. So cos 90 will be 0. So the remaining value is only 40 is equal to P square plus Q square. So it is equation number 1. Remember this equation number 1, P square plus Q square equal to 40. We will use this equation later on. For the case number 2, when theta equal to 60 degree, replace all the values from case number 2 in the same formula. So R square equal to 52. So P square plus Q square unknown, 2PQ unknown and theta will be 60 now, which is cos 60 equal to 0.5. The bracket P square plus Q square will be replaced from the equation number 1. From the equation number 1, P square plus Q square equal to 40. So just replace over here, you will get 52 equal to 40 plus PQ. Why it is PQ only? This 2 and this 0.5 will be cancelled out because of multiplication. So final answer will be, by subtracting 40, you will get PQ equal to 12, equation number 2. So equation number 1 is P square plus Q square equal to 40. Equation number 2 is PQ equal to 12. Now from these two equations, by elimination method, by replacement method or by any method, we have to calculate P and Q. So for that, you know the formula of P plus Q whole square, which is P square plus Q square plus 2PQ. And replace all the values. P square plus Q square means 40. 2 will be as it is and PQ will be 12 from the equation number 2. So final answer will be 64. Total will be 64. P plus Q whole square equal to 64. By rooting on both the side, so P plus Q equal to 8 only. Let us see on the next page. You can see over here P plus Q square whole square equal to 64. So by square rooting, P plus Q equal to 8. So this is equation number 3. Very most important. Now similarly for the next formula, P minus Q whole square. So what is P minus Q whole square? It is P square plus Q square minus 2PQ. Okay, you can see over here. Now from the equation number 1, remember equation number 1, P square plus Q square equal to 40 and PQ will be equal to 12. So answer will be 2 times 12, 24, which is subtracted from 40, you will get 16, and by square rooting on both the sides, P minus Q equal to 4. So this is equation number 4, which is very important. So from equation number 3 here and from equation number 4 here, you can just eliminate. Elimination method as in the 10th or 9th standard. So from the third equation, P plus Q equal to 8. From the fourth equation, P minus Q equal to 4. By adding these two equations, Q will be cancelled out. P plus P equal to 2P and 8 plus 4 equal to 12. So P equal to 12 by 2. So P equal to 6 kilonewton. So now first answer is ready for you. P equal to 6 kilonewton. And from the equation number 1, P plus Q equal to 8. So replace P equal to 6 over here. 6 plus Q equal to 8. 6 will be subtracted. So Q equal to 8 minus 6 equal to 2 kilonewton. So now P equal to 6 kilonewton and Q equal to 2 kilonewton. So this is a very most important numerical, very tedious, very calculative, mind approaching numerical. So your maths will be powerful for this. Maths powerful. Okay, so your mathematics will be required again and again. Let us see one more numerical. Example number 10. This is again very most important. What is given in the data? The resultant of two forces P and Q. The resultant of two forces P and Q means R, which is at right angle to P. So here it is in the figure that this resultant R is at right angle to P. You can see over here, right angle means 90 degree. So it means alpha, this alpha is given to you, which is 90 degree. You can see over here. What we have to find? We have to prove something. Show that, means prove that the angle between the forces is cos inverse of minus P by Q. Angle between the forces means theta. So we have to find theta, or we have to prove theta, which is equal to cos inverse of minus P by Q. So you can see from the formula that tan alpha is equal to Q sin theta upon P plus Q cos theta. We are knowing the alpha, which is 90, so tan 90 degree is equal to same formula. So tan 90 you can check in your calci, or you can remember from the trigonometry, tan 90 will be infinity. So infinity is equal to the same formula Q sin theta upon P plus Q cos theta. Now from the mathematics, when the answer will be infinity, then the denominator of the term will be 0, must be 0. So from this formula, the denominator P plus Q cos theta must be equal to 0. Then and then the answer will become infinity, right? So now from this equation, just remember cos theta only. So P will be opposite side, which is minus P, and Q will be in the denominator, which is minus P by Q. So finally cos theta is equal to minus P by Q, and theta will be equal to cos inverse of minus P by Q. So hence we have proved that the angle between the two forces theta is equal to cos inverse of minus P by Q. So this is also one more variety of the numerical. Here it is, example number 10 completed, in which we have to prove something. We have to prove the angle between two forces theta is equal to cos inverse of minus P by Q. Let us see one more numerical. Now the most important, most practical, most comfortable numerical is there for the subject point of view. Example number 14. First of all, I will just roughly explain this figure. This is the river or canal, you can say, having two opposite banks. This is the canal bank first, and this is the bank number 2. Two opposite banks. Banks means you are knowing very well. Now from both the banks, the different points C and A, two ropes are there, CB and AB, which is connected to this boat. This is the boat which is trapped in the canal, in middle of the canal B, and we have to require to keep this boat moving or to keep the boat out from the canal. Okay, so the resultant will be in this direction, which is given in the data. The upper angle will be beta, the lower angle will be alpha with the horizontal axis. The rope length of BC is 100 meter. The rope length of BA is equal to 150 meter. The force Q will be 1500 Newton. Force P will be unknown. Resultant force also unknown. Right? And the canal width, vertical width of the canal is 100 meter. So the two parts are 50 meter, 50 meter itself. Now this is the rough explanation of the figure. Now you just read the data carefully and then after watch the figure again. Then you will clear the figure and then after we will start the numerical. So what is given in the example number 14? It is given that a boat B is in the middle of a canal 100-meter wide. So boat B is exactly in the middle of a canal of 100-meter width. Middle means 50-meter, 50-meter, two partitions, and is pulled by two ropes, BA 150-meter long and BC 100-meter long, by two locomotives on the banks. So C and A are two locomotives. The pull in BC being 1500 Newton. So Q is equal to 1500 Newton. Pull in BC. Tensile force. Find the pull in BA. So we have to calculate pull P in force in rope BA, so that the boat moves parallel to the banks. Remember, where the boat is moving parallel to the banks, means in horizontal direction, this direction. So in this direction we have to find resultant. Find also the resultant force on the boat. We have to calculate R and P both. Clear? Hope you are clear. Now let us start the sine alpha. What actually I want the value of alpha and beta, these two angles from the figure, which can be found out with the help of trigonometry. You can see this is right angle triangle. You can see just this is a right angle triangle. Okay. So what is beta? If you are taking lower portion, then this will be the right angle triangle. You can say this is the right angle triangle. This is the right angle triangle, right? So in this, what is sine alpha? Equal to opposite upon hypotenuse. So what is the opposite of alpha? This is the opposite of alpha, which is the canal width 50 meter. So here it is 50. And what is hypotenuse of this triangle? It is 150 meter. You can see in the figure. So 50 by 150.333 in your calci. By doing sine inverse in your calci, you will find that alpha equal to 19.47 degree. Similarly, same method for the upper triangle. What is sine beta? Opposite upon hypotenuse. So what is opposite of the beta? This is the opposite of the beta, which is 50 meter again. Hypotenuse will be 100. So sine beta equal to 50 upon 100, 0.5. So inverse of 0.5, sine inverse will be 30 degrees. So beta will be 30. So here it is alpha, here it is beta. If you add beta and alpha, you will get theta equal to alpha plus beta is equal to 49.47. Why we are adding this? To make the parallelogram. You can see from point B, you can see the different color. Let us take yellow color. Then from point B to C, oh, yellow is not visible properly, I think. Let us take red color. So from point B to C, and from C to resultant axis, from resultant axis to point A, from point A to again back to point B. So this is the parallelogram. So in this parallelogram, if you add alpha and beta, you will get theta as per the theory, and diagonal will be the resultant, and the angle between R and P force, which is alpha, the direction of the result. Okay, hope you are clear with this. Remember theory while doing this example. So tan alpha equal to Q sin theta upon P plus Q cos theta. Replace all the values of alpha. Q is known to you. Theta is available to you now. So only and only unknown is P. So by simplification, by cross multiplication, you will get P equal to 2254.95 Newton. Again remember, while doing the calculation after decimal point, you have to take 3 to 4 digits. Let us find resultant now. In the next page, what is resultant? R equal to under root of P square plus Q square plus 2PQ cos theta, in which P is available to you now. Q is already given in the figure 1500. P is available to you now. Q is given in the figure, and theta we have calculated 49.47 degree. So by simplification, you will get that R is equal to 3425.0 Newton. So this is the magnitude of the resultant. Let us see last numerical of this topic. Example number 15. It is very much important and last numerical of this lecture. Find the angle between two equal forces P. Now the two equal forces means P equal to P and Q is also equal to P. Both the forces are equal, and we have to find theta, the angle between these two forces. If the resultant is equal to 0, so resultant is given to you, which is 0. If you don't watch the figure also, then also the sum is very easy. Just replace the formula. What is formula? R equal to under root of p square plus q square plus 2p q cos theta. What is given? R equal to 0, p square equal to p square. Now q is also p, so q square equal to p square. Again p equal to p, q equal to p, theta will be as it is. So p square will be common out from this equation and you will get 2 plus 2 cos theta. 2 is also common out. P square root will be p and the answer is 1 plus cos theta in the bracket. So now if you remember from the trigonometry, or you can find out the formula from the Google, or you can find out the formula from your textbook. Actually this formula is coming into the 11-12 standard. Okay, 11-12 standard. So you have to read the mathematics textbook. 1 plus cos theta is equal to 2 cos square theta by 2. So in the replacement of this bracket, I am replacing 2 cos square theta by 2. So 2 into 2 will be 4, square root will be 2. So 2p outside and under root of cos square theta by 2. So root will be again cos theta by 2. While the 2p is going in the denominator of 0, it will become 0. So final answer will be cos theta by 2, which is equal to 0. By doing cos inverse of 0, you will get 90 in your calci. So theta by 2 equal to 90, so theta equal to 180 degree. So the angle between two equal forces P and P is equal to 180 degree. Just recall this formula. If you are having any doubts, then rewind the video and rewind the video lecture. You will get the solution of your doubts. So students, this is the lecture number 2 in which we have discussed the numericals based on law of parallelogram of forces. Let us close the lecture number 2 over here. We will meet in the lecture number 3. Till then, thank you very much. Goodbye.